Alright, so I wanted to cover some random sampling. I know that people get a little anxious about math, and so that's why I didn't have you turn in this stuff today. I want you to take a look at it. I'm going to show you how I set up the first two problems, so you can compare it how you set up the first two problems. If you set it up like I did, then you're probably going to do the rest of them correctly. If you get the same answers I got, then you can feel comfortable. Like, okay, I got it. If you didn't, then you can be like, okay, what did I do wrong? Okay, how did he do it? So that's what we're going to do. So first off, these are the reasons why you would do random sampling. Okay, so populations don't move, they're plants, it's a small population, small area, microscopic organisms. The most popular one is because it's a plant, it's not going to move. This is really, really popular with plants. Now, you need at least 3 squares. So again, at least 3 squares need to be measured. Does that mean you only measure 3 squares? No. So, and I'll show you this on one of the problems from your problem set. You need how many squares in the whole area or the total number of squares. So it kind of looks like this. Like right here, the total number of squares is 16. This number is going to change depending on your area. So this is the easiest one, total number of squares. Just how many total squares do you have? Multiplied by the average per square. This is where most people get thrown off. How do you find the average? Again, you want about 3 of them. Does that mean you only do 3? No. Okay. So in this case, we're going to use 3 squares. So in this square there's 4, in this square there's 2, and in this square there's 1. 4 plus 2 plus 1 gives me 7. Now to get the average, I divide it by the number of squares that I measured. In this case, it's 3, so 7 divided by 3. So what is the average number of dots per square? Well, 2.33. Now, if you get a really, really long number, so 2.33333333, you can go ahead and just multiply that by the number of squares. So like you don't have to round it right at this point. Your final answer needs to be rounded. Your answer, so long as it falls in a range, okay, in a range, you'll be okay. So like between this number, if your answer is between this number and this number, you're fine. So in this problem, I have an estimated, an average of 2.33 times 16 squares gives me an estimated population of 37.3 dots. And that's it. Okay, cool. Again, if you need to see this, rewind it. So I'm going to be doing some sample problems here for you. Just like I said, so you feel more comfortable. First question is, out of the reasons that we gave you in the notes, why would sampling, why would random sampling, or we also call it quadrant sampling, why would you use it for these flowers? Again, just go back to the notes. It's like the first thing I said. Like, why do we use it? This is actually the perfect reason, the main reason we use it. Okay, so just go back in your notes and look at that. All right, so let's look at this. How many students are there in 10 H-building classes during second period based off the data? Again, we don't want to measure all 10 classes. So we go to H6, to H2, and H5, and we count how many students there are. First off, what's the average number? And what is the population estimate based on those 10 classes? So this I already did for you. So again, if I'm going back and forth between the problem and this, here's how I set it up. Again, 30 plus 22 plus 20. So here is where I made an error. Like I said, no matter how smart you think you are, you might get something wrong if you're working too fast. And that's what happened here. So on remind, here is I will put a little easy right here on remind. So you're going to flood my remind saying, Avila, you added wrong, or just put added incorrectly. 30 plus 22 plus 20 is not 45. It is not 45. It is 72. If you can do me a favor and fix this. So it's not 45 divided by 3. It should be 72 divided by 3. In which case the average is not 15. The average would be 24. So really it should be 24 times 10, and this answer should be 240. So again, a simple addition error could lead to you making a mistake. And it doesn't mean you don't know what you're doing. I know what I'm doing. It's just I was working too fast. I went way too fast for some reason, and I added incorrectly. So here the average, again, we're going to change this to 72. And we are going to change this to 240 students right there. So let that be a lesson to me to always double check your work. Always double check your work. All right, so anyhow, let's tackle number 3. So there we go with the updated look of 72, 240. Again, it's 30 plus 22 plus 70, or plus 20 equals 72. 72 divided by the 3 classes that we went in and measured. 24 students as an average. 24 times 10 classes total gives us the 240. All right, now let's take a look at question number 3. Hopefully I don't add wrong this time. All right, so in this case, we wanted to figure out how many students there are in 57 classes based off the data. So in this case, we went and we measured 1, 2, 3 classes. All right, so let's come back over here. So we know our total is 57. So now we need to set up our average. So we need to come back. Okay, how many students did we have total? So 30, 28, 32. So set that up like that. So we have 90 students total in these 3 classes. Now we need an average. So 90 divided by 3. $30 students. 30 students. This is our average. All right. So now it's pretty simple. It's just 30 students as the average times 57 classes total. And then I'm going to box my answer right here. And I don't expect you to do this in your head. Like I said, if you feel more comfortable using a calculator, okay, bring your calculator. Just do 30 times 57. Gives us 1,710. 1,710. 10 students as an estimated population size. So let me be nice and do one more for you. Because again, that was my mess up. Let's go back to here. Actually, we're going to skip number 4. Let's go to number 5. So this one is going to be the same setup, except instead of students, you're using rose bushes. Instead of classes, you're using 37 square meters. So let's skip number 4 and let's go to number 5. Because this one is a little bit different. I'm setting up my binder paper right now. All right. So this one, like I said, you still need to do this problem. I'm just skipping it because it's the same as these. All right, so number 5. So for number 5, instead of counting 3 boxes, we went and we counted 5. 1, 2, 3, 4, 5. So I'm going to take 11 plus 7 plus 9 plus 5 plus 3. And so this is what I'm doing on my binder paper on the other side. So I'm taking all these numbers right here. Use a calculator if you want. Total all that up. It equals 35 as an average. So again, this is my average right here. Average trees. Okay, so now we take 35, which was our total, and we divide it by, well, how many did we measure? Like how many squares? This time we did 1, 2, 3, 4, 5 numbers, or 5 squares. And that gives us 7, as the average. Okay, so 7 trees. Like so. All right, so now we take the average of 7 trees times how many total squares. So we need to go back and take a look. All right. So in this case, how many total squares are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 20, 25. So in an estimated 25 square meters. So we come back. 7 times 25. And that will equal our estimated population size of trees. So again, we can always come back to our handy dandy calculator. Go 7 times 25 if you need to. So just double check. 7 times 25. And it says in this area there's probably 175 trees without having to count all of them.